Hi again to everybody. So let's now proceed with the last section of our solid mensuration part. This is the very last section of solid mensuration part. Then we proceed to analytic geometry part. Okay, and this will now be about the sphere. And by definition, we are given a sphere is simply a solid bounded by a closed surface, every point of which is equidistant from a fixed point called a center. The easiest way to determine the sphere is like considering, go to this diagram. So if you will draw a circle, then draw the diameter of the circle. If you make the diameter of the circle as an axis of rotation. So if you now rotate this axis, you now form your sphere. Then if you draw circles such that your circles will be passing through this diameter, okay, you will be able to draw your great circles. But if you will draw a circle not passing through the diameter, you now call it a small circle. And under this section, we have two formulas to consider. One is your surface area. It's given by 4 pi r squared, where r is the radius of the circle. So going back in the previous diagram, the radius of the circle is, or the radius of the sphere is any line segment coming from the center of the sphere to any point on the surface of the sphere. So that's the radius of the sphere, or it's the radius of the great circle. And then for the volume is given by 4/3 pi r cubed. Again, r is the radius of the sphere. And in your module, there are two problems only given there. So let me solve one of the problems given. Then you can just review the other problem. And the problem goes a right circular cone. So we know what a right circular cone is. We have already discussed this in the previous section. Is inscribed in a sphere such that the slant height of the cone has length equal to its diameter. The slant height of the cone. So if you will go to this diagram, if that's the cone inscribed in your sphere, this will now be your slant height. And the slant height is equal to the diameter of the radius of the sphere, diameter of the circular base, I mean. And where is the diameter of the circular base? Of course, this entire length here will now be equal to the slant height L also, because it's the diameter of the circular base. And we have to solve two things here. Find the radius of the base of the cone. Where is that? It will be this section here. So let's call that as R. Let R be the radius of the base, and let's also have the altitude of the cone. Which one is the altitude of the cone? So if we will proceed, if we will proceed in dropping a perpendicular line here, then this entire segment will now be the altitude of the cone. We can call that as H, the altitude of the cone. Okay, so what do we have in the uh, problem? So first, let's represent R is the radius of the circular base of cone, while H is the altitude of our cone. If you will now look at this diagram here, what else can we obtain? If we connect this center to this point here, of course, that will also be the radius of the sphere, which will be 6 inches. So that will also be 6 inches. Okay, what do we need to solve? Letter A. We need to solve the radius of the cone. And where do you find the radius of the cone? From this right triangle here. So if you will now isolate the right triangle there, this will be 6 inches. This will be your R. In trigonometry, we have said that a right triangle will be solvable if there are at least two given parts. Either you have two sides given or one side and an angle. So what else can we supply here? Definitely we cannot supply this this side of the triangle because it's unknown. Side na yun. So what can we supply here? Okay, look at the diagram. This is L. This is also the slant height L. The diameter of the circular base is also equal to the slant height L. So ibig sabihin, the triangle that we have here is equilateral. And from trigonometry also, an equilateral triangle is equiangular. So if that's equiangular, this must be 60, this must be 60 as well, and this entire angle here is also 60. Okay, what else do we know? But another triangle is formed here. Look at this triangle here. 1, 2, and 3. This triangle here. But this is 6 and 6, so that makes the triangle here, this green triangle. Let me draw this green triangle. The green triangle here is what? An is an isosceles triangle. Isosceles. This is 6. This is 6, therefore it's isosceles. So if it is isosceles, then the base angles are equal. Okay. Meaning, isn't it that if we also draw this, we get the same triangle here. Same triangle lang yan. Therefore, if those triangles are the same, then this angle 60 is divided into 2, so that must be 30, 30. 30 and 30, if this is 60, then this must also be 30. And if that's 30, then we can now label this as 30 degrees. And if that's 30 degrees, it means that from this right triangle, R now is solvable. And what function can we use? Cosine, because we have adjacent and hypotenuse. So we have cosine 30 degrees is equal to, what's cosine 30 degrees? Adjacent over hypotenuse. That's 6 inches. So cross multiplying, R will be 6 inches multiplied by cosine 30 degrees. And computing this one, you will now have the value of your R. So we are done with the value of R. Next, we go to the altitude. So if we will now solve for the altitude of the uh, circular cone, let's go back to the diagram and let me redraw the right triangle that we have isolated earlier. Okay, we have labeled this as H, we have labeled this as L, which is of course equal to 2R, and we have said that this will be 60. But again, para hindi na natin gamitin actually itong triangle na to, we can go back and use the small triangle here. Balikan tayo rito. Why? Again, in this diagram, we have the total length H is this. This is 6 plus itong section na to. So if we will call this section here, let's say as X, then it that, for letter B, let me place it here. For letter B, it's just H, which is the altitude or the height of the cone, is equal to 6 inches plus x. Okay, so to solve for x, either you use your sine function, you have sine of 30 degrees is equal to x over 6 inches, or x will be equal to 6 times sine 30 degrees. So if you can compute now the value of x here, just inject the value for this, then that's it for the value of it. Okay, so that completes the solution for this particular problem, and that ends the section for solid mensuration. Okay, so we will be considering now the section on analytic geometry.